Hello everyone, my name is Alex Taylor. I use he, him, his pronouns. I'm spending a lot of time during this quarantine hanging out with our 2 family cows on our farm in Vermont and playing with my dog. We're also in the middle of potentially a big snowstorm, so I'm looking forward to spending a lot of time outside over the next few days, taking some photos of the snow. So as I said outside, my name is Alex Taylor. I study chemistry in the College of Arts and Sciences. I first thought I'd tell you a little bit about what I'm up to while classes are being held remotely. So I'm spending a lot of time at home currently. I'm also enjoying going on runs around Vermont. So I live in central Vermont, where there aren't many people. I'm also enjoying reading some new books that have been on my list for a long time and baking remotely with some friends. So first, I thought I'd tell you a little bit about why you should study chemistry, because I'm a little bit biased and I think you should consider it no matter where you go to college. So chemistry is a really cool way of approaching the world around you. It's a set of tools for understanding how atoms and molecules interact with each other. And then when you understand how they interact, you can build and predict and create a whole new understanding of the world. So with chemistry, we sort of divide it up into 4 different segments. There's analytical chemistry, which is what I find most fascinating, which is looking at how much and what kind of atoms and molecules are present. So we use analytical chemistry all the time, for example, at understanding what kinds of compounds we would find in the environment, or another example would be detecting the coronavirus in a blood sample. Another form of chemistry is physical chemistry. So this is looking and understanding at the fundamental structure of atoms and molecules, and understanding how that fundamental structure and behavior of the electron and other subatomic particles in atoms allow the molecule to behave the way it does. And so physical chemistry is really powerful because it sort of lays the groundwork for the way that atoms and molecules behave fundamentally. The third category of chemistry is that of organic chemistry. And so organic chemistry is really exciting because we take this fundamental building block of most life on this planet, carbon, and we put it together in interesting ways to create thousands, if not millions, of molecules. And so organic chemistry is really powerful in both pharmaceuticals, but also in understanding the ways that molecules can be put together to create new and powerful properties. The last category of chemistry is inorganic chemistry. And inorganic chemistry is sort of the other half of organic chemistry. And with inorganic chemistry, we look at atoms that you'd find in the middle of the periodic table. And so those are things like iron and tin and gold. And what we can do with inorganic chemistry is put some of these elements in the middle of the periodic table together with other elements and create radically new and profound molecules that can do cool things. So for example, heme, which we would find in our blood, is used to carry oxygen to our various organs and cells. And the transition metal iron, which is used inside of heme, was described by, or is described by inorganic chemistry, and its properties are described by some inorganic chemistry tools. So at UVM and in a chemistry program, you'll get a tour of the 4 sort of main areas of chemistry. So in a chemistry program, such as what you'd find at UVM, you'll complete sort of a tour of the 4 areas of chemistry. What I find most exciting about chemistry, though, is not really the tour of the 4 areas, but rather the way of thinking that chemistry can impart on you. And I think this way of thinking about chemistry is quite unique to UVM. While I'm completing a BS in chemistry, I'm also taking a large number of classes that are outside of the chemistry department. And so I'd say about 60 to 70% of my classes are in the chemistry department, and 30 to 40% of my classes are outside of the department. And what this allows me to do is not only get a very deep treatment of chemistry and allow me to specify in areas of chemistry that I find interesting, but it also provides an opportunity for me to experience other parts of the academic sphere. What's been really useful for me in this approach has been in allowing me to reframe the way that I think about chemistry. So originally when I thought about chemistry, when I first came to college, I considered it as a means to an end. So chemistry was really a way of creating a new molecule or understanding how much, for example, iron is in some blood. But what I'm realizing, especially after taking all these courses outside of the chemistry department, chemistry is really about being able to put on a metaphorical pair of glasses and imagine a world around you where you can see exactly how atoms behave, and you can predict the way that they would do things if you were to put them, for example, in a new environment, or if you were to add other atoms into your system and cause them to react together. This is all, if you think about it, really a complex system of interactions. And the same is true in storytelling. And so in my sophomore year, I took a screenwriting class in the film department where we were tasked with writing a screenplay. And what I realized in writing my screenplay was that it was almost identical to the way I would approach writing a lab report. And although the output of my work was different, obviously a lab report is a technical piece of writing and a screenplay is a creative piece of writing. In a lab report, there are characters, and those characters are the different chemicals and the different atoms and molecules that I'm reacting. There are also plot points. Just like in a screenplay, in a lab report, I mixed chemicals together or I mixed atoms together, and then I saw what happened. And then there are outcomes. There are some winners and there are some losers. So in a lab report, I describe not only what happened when I mixed these chemicals together, but what that meant for what I was trying to create or what I was trying to understand. And so what I found really profound about this liberal arts model to approaching chemistry and learning chemistry is that I'm able to find connections between the chemical world and other parts of academics that I find really interesting, like screenwriting. I think this approach to learning and this approach to thinking about the world around us is unique to UVM, and I can't wait to see you all here in the fall. Don't hesitate to reach out if you have any questions.